Hello everyone, and welcome back to a new video in programming the finite element method using MATLAB. In this video, we are going to continue using the totally overpowered OP tool of MATLAB that is called Symbolic Math. We're gonna need it because we're gonna deal today with trapezoidal shear and trapezoidal moment and the loads, equivalent nodal loads, that result from those two dudes. It's going to be a symbolic math lecture, so I hope you would dim your brightness a little bit because we're going to use the MATLAB 2017 that I have, which doesn't have dark themed desktop. So in order to preserve your eyesight, I recommend you lower the brightness a little bit until the symbolic math section has been done. I will tell you once it's done. Now before I start, I want to remind you that this is part of a double playlist, which is one of them is about the finite element method theory and programming, and the other one is the pure programming playlist. And of course, my dear channel members have access to all the source code, but if you're not a channel member, then don't worry, because every single line of code that I write here will be shown in front of you, which means you can write along and you will have the exact same code as me. So with that being said, and without further ado, let's jump into the video, so sit back, relax, and enjoy the show. Alright, now we are digging deep here because now we need to deal with the shear, which is a little bit more complicated. Now I will just basically copy this entire signature and paste it here as per usual. And I'm going to fire up the symbolic math of MATLAB 2017 because I don't have the symbolic math on my new MATLAB. And it takes too much time to download, and my internet connection today is not really the best. So here I have a new function declaration, I have L, and I have all those things. I will call it once again W1 and W2. Why do I have local input 3? I think there is something messed up in this because I only need 2 values. Why are there 3 values? I think that's just an error in the copy pasting. Let me just delete this and check if the error happened again. No, okay. So it's only W1 and W2 and the fan bar. Fantastic. And I think I messed something up because in the previous video, I called for L despite the fact that it's already here. Wait, am I passing in the L? Yeah, I'm passing in the L. So why should I even call for it? So there's no need for calling for the L. There is no need for getting a loss, by the way, or an L, which means this is useless now. Same thing goes for this one, because I'm not taking an L, hopefully. I would not need the fan bar, which now would cause havoc, because now here, I'm not taking the L because I have it. So now this fan bar is no longer needed. Yep, that's it. Meaning that the signature, the calling signature here is now incorrect, because when you call for axial, we don't need to pass in the fan bar. And when you call for shear, we're not going to pass in the fan bar. On trapezoid, we're not going to pass in the... Actually, we're not going to pass in the fan bar for any one of those. Okay, why did I pass it before? Because I was taking the length? What a shame, I could have it. Or maybe I'm just overthinking things. Maybe I'm just being too perfectionist. I should just let it go. Okay, now let's dive into it. So, first things first, I think I still am able to take this and copy this entire thing as my comment, with a change here that I don't have only 2 shape functions, I have 4. Because in the beam bending, there are 4 shape functions. If you remember them, good for you. If you don't remember them, I've explained them in my finite element method lectures. So now, a warning, dear viewer, it's gonna get bright because I'm gonna take my other MATLAB 2017, which doesn't have a dark mode, so it's going to be suddenly bright. For those of you who are using the dark mode desktop, please lower the brightness. Okay, I hope you lowered it. This is the MATLAB 2017 where I do my symbolic math stuff. Now here, that's the derivation for axial. Let me here just undo everything by saying CLC and clear, so I'm undoing everything. What a waste. And now I'm copying this symbolic stuff because I'm going to do it again. I'll just comment this entire block. I can comment it out if I want to activate it. So now we go CLC and clear. We have everything here. However, now I have N3 and N4 because I have 4 shape functions. And I have Q1, Q2, Q3, and Q4 because I have 4 outputs. Fantastic. N1, which is the shape function 1 minus 3 over L square, x square. And then I have plus 2 over L cube multiplied by x cube. This should be the shape function of N1. I can also rewrite it in Derived style, which basically says 1 over L cube, that's Derived Logan style, multiplied by 2 multiplied by x cube minus 3 multiplied by x squared multiplied by L plus L cubed. This is Daryl Logan's book, Daryl, page 155. And 3 actually. It's going to equal 1 over L cubed according to Daryl Logan's book multiplied by negative 2 multiplied by x cubed plus 3 multiplied by x squared multiplied by L. I'll continue writing N2 from Daryl Logan's book. This is page 355. Okay, so those are the shape functions. Now, we need to perform our calculations here. Now remember, I can actually copy this and paste it. I think I can do that. I can just copy this entire thing and paste it here, because Q1 is the integration of load 1, shape function 1, plus integration of load 2, shape function 2, shape function 1, plus integration of load 3, shape function 3, that's for Q1. As a matter of fact, I can do everything here, Q2, Q3, and Q4. So that's Q2, that's Q3, and that's Q4. And here, of course, I would need to change the shape function. That's 2, 3, and 4. And here again, 2, 3, and 4. And here again, 2, 3, and 4. And this, ladies and gentlemen, would give me the equations that give you the equivalent total forces for a shear load. Now here, those are Q1, Q2, Q3, and Q4. What I also need to do is I need to define those Qs. So I just copy this, paste it here in the Symbolic Math tool. Okay, and now I have to push the F5 button. So let's push the F5 button and see what happens and get those juicy equations. Now here, those are the equations for Q1, Q2, Q3, and Q4 based on the Symbolic Math toolbox of MATLAB. I am going to benchmark this against my Strado and see if the Symbolic Math, I'm putting my trust in MATLAB's Symbolic Math toolbox. You could do the same in the Symbolic Math toolbox. You have the source code here, and you can derive the equations like me. Nothing special here. How do we know if it works or not? Well, in our benchmarking session. Those are going to be at the end of our video series. So now we have Q1, Q2, Q3, and Q4. I could copy them and go to the MATLAB and paste them there. Once again, the warning that the brightness is going to change in 5 seconds because we are going to go to the dark MATLAB, which will happen exactly in 5 seconds. Okay, so switching to dark MATLAB, I paste those equations and I Control-I them in place. I remove those and I have Q1, Q2, Q3, and so on. But I think there's still some stuff missing because I don't have A and B. There are equations with A and B. Those are undefined. So I'm just going to go back to one of the previous ones and copy this and paste them here. So yeah, that's another function I hope conquered. We still need to benchmark it, but that's enough for this video today. I hope you enjoyed. And in the end, I want to give another Symbolic Math sized shout out to my dear channel members in the contributor level and the helper level whose names are going to be shown on the screen. I want to thank them from the bottom of my heart, as their support of the channel is priceless to me and enables me to provide you with videos hopefully on time and with a certain quality I try to achieve, and for that I am forever thankful. In the end, I hope that you enjoyed the video and you found it beneficial. If you have enjoyed the video, then please consider liking, sharing, subscribing, commenting, and so on. Especially subscribing, because it helps increase the reach of my channel. As per usual, this is the Civil Engineering Essentials channel. I will catch you in the next video. Bye bye.